So here we have question 3, and 3.1 says, given the arithmetic sequence w minus 3, 2w minus 4, and 23 minus w. So we are given the first three terms. We've got term 1, term 2, and term 3. 3.1.1 says, determine the value of w. Now, it's important to remember that whether you are working with an arithmetic or a geometric sequence, as long as you have a variable in that pattern and you need to solve for that variable, you work as if you are calculating what is constant. Now, in an arithmetic sequence, what's constant is d, the difference. And if we're not sure what the difference is, we calculate it using term 3 minus term 2 is equal to term 2 minus term 1. So that is exactly what we are going to do. So here is our formula. Now substituting accordingly, term 3 is 23 minus w. Then we've got a minus, and I'm going to put term 2 in a bracket, which is 2w minus 4. So on the right hand side, we've got 2w minus 4 minus term 1, which is w minus 3. And all we have to do from here is work algebraically until we solve for w. On the left hand side, I'm going to take that negative in front of the bracket and multiply it into the bracket with both terms. That gives me negative 2w and positive 4. We're going to do the same thing on the right hand side. Negative goes into the bracket and gives us negative w and positive 3. Let's simplify each side. So on the left, we've got 23 plus 4, which is 27. Negative w minus 2w is negative 3w. On the right hand side, we've got 2w minus w, which is just w. And negative 4 plus 3, which is negative 1. Now, since we're trying to solve for w, we want to make w the subject, so let's try to get all of the w's alone on one side. I'm going to choose to take this negative 3w to the right so that it can add onto the w to give us 4w. Let's take that negative 1 over to the left. It is going to add, and we've got 27 plus 1, which gives you 28. To get w alone, we are going to divide throughout by 4, and we end up with w is equal to 7. Now that we know what w is, we can take that value and substitute into each term so that we can get actual values as the term. I'm just going to do that here because we may need it to answer the next question. Since w was 7, our term 1 becomes 7 minus 3, which is 4. Term 2 is going to be 2 times 7, that's 14. Minus 4, we get 10. And term 3 would be 23 minus 7, which gives you 16. And this is correct. We can see that this forms an arithmetic pattern, where the difference here each time is 6. We are adding 6 each time. Now, that is actually the next question. Write down the common difference of the sequence. It is only 1 mark, so there would be 1 mark allocated to the answer itself. So all we have to say is d is equal to 6. Okay, let's move on to 3.2. It says the arithmetic sequence 4, 10, 16. So this looks like it's the same sequence from above. That is the sequence of the first differences of a quadratic sequence, with the first term equal to 3. Now, yes, we know that for a quadratic sequence, it has 2 differences, and the first difference forms an arithmetic pattern. So what they're saying to us is that this arithmetic pattern 4, 10, 16, these values, these terms, forms the first difference of the quadratic. And with regards to the quadratic, we are given term 1. So term 1 is equal to 3. Now the question itself says, determine the 50th term of the quadratic sequence. So we need to ask ourselves, how can we use what we have to get what we need? Since the 50th term is quite far from the first term of the quadratic, it would be best if we can determine the general term of the quadratic pattern. And once we have that, we just need to substitute 50 in place of n. So let's work towards getting the general term. Now, to write down what we are given, I'm going to let these spaces represent the quadratic. And the only thing I know here is what the first term I know is what the first term is. And then to get the first differences, those are going to be the values 4, 10, and 16. That is the first difference, which is arithmetic. And from here, we can get the second difference, which we know is 6. We are adding 6 each time. So second difference. Now it's actually quite simple here for you to get the general term of this quadratic pattern, because remember, to do that, all you need is the first term in each row. And working from the bottom, we have 2a. The value above that would be 3a plus b, and then a plus b plus c. So determining the general term in this case is quite simple because we have all the values that we need. Okay, so we're going to have 2a is equal to 6. Divide throughout by 2, a is equal to 3. Then let's go above that. 3a plus b is equal to 4. That's going to be 3 times 3 plus b is equal to 4. 3 times 3 is 9. We can take the 9 over to the right hand side. It is going to subtract. So b is equal to negative 5. Working with the term above that, a plus b plus c is equal to 3. So a is 3, b is negative 5, plus c is equal to 3. I just want to simplify the left-hand side first. That gives me negative 2 plus c is equal to 3. Take the negative 2 over to the right. It is going to add on. So c ends up being 5. Now we can write down our general term. Remember, it is in the format an squared plus bn plus c. So substituting in here, we would have 3n squared minus 5n plus 5. And now remember, the question required you to get term 50. So we're going to substitute 50 wherever we have n. That would be 3 into 50 squared minus 5 times 50 plus 5. So on the right hand side, that is going to equal to 7255. And that is what was required of you to calculate in this question.